This is the second part of our lesson on confidence intervals. In the last video, we have already described what is confidence interval, point estimate, interval estimate, and other basic terms about this lesson. This time, you should be able to explain the general form of a confidence interval, and in our next video, we will be applying it to different statistics and conditions. Also, in our next videos, you will be constructing a confidence interval, and then you will be interpreting the confidence interval that you will be constructing. Now, the key terms for this video are the following. So we have critical values, confidence level, the margin of error or error bound for a population mean, confidence intervals, Z distribution, and T distribution. The presentation in this video will not be too difficult, but it will be simplified such that you will be able to understand what is meant by these terms. We had our example in the last video about the cholesterol levels of males of 12 individuals, and we were able to arrive at a confidence interval 191 milligram per 100 ml to 243 milligram per 100 ml. But the question is, how did we construct this 95% confidence interval for the population mean of serum cholesterol levels of all males in the United States? We have the general formula for the confidence interval, where we have the point estimate minus the margin of error, and then the point estimate plus the margin of error. Now, commonly, the point estimate that we will be using will be the sample mean, since we will be constructing a confidence interval for a population mean. So the point estimate that we will be using will be the sample mean given our sample data minus margin of error, then the sample mean plus the margin of error. Or we say that the margin of error is the same as error bound for a population mean. Now, in getting confidence intervals, there will be two situations that we need to address. First one is when the population standard deviation is known. And the second is when the population standard deviation is unknown. Now, what will happen if we know the population standard deviation? If we know the population standard deviation, we will be guided by the Z distribution. So what is this Z distribution? This is likened to a normal distribution. And the formula in constructing the confidence interval when the population standard deviation is known would be this one. So we have the sample mean minus our critical value, which is Z sub alpha all over 2 times the population SD divided by the square root of the sample size. That's the lower limit of the confidence interval. And the upper limit would be sample mean plus the critical value times the population standard deviation over the square root of the sample size. Now, if you notice, the multiplier for the critical value is the standard error of the sampling distribution of the sample mean. So that standard error is the population SD divided by the square root of the sample size. Now, on the other hand, if we don't know the population SD, which is the reality, okay, we will be guided by the T distribution. And our formula would be similar, only that we will change now the critical value based on the T distribution. And instead of using the population SD, we will be using now the sample SD, which will be based on our sample given. Now take note that when we make our confidence intervals, it will be affected by the population variability and of course the sample size. The lesser the population variability, the narrower would be the confidence interval, meaning the values of the lower limit and the upper limit of the confidence intervals will be close. And the larger the sample size, the narrower also would be our confidence interval. Now, what are the critical values that we commonly use when the population standard deviation is known? So this will be based on the Z table or the normal distribution. The common confidence levels that we use in constructing confidence intervals would be 90%, 95%, 98%, and then we have 99%. The confidence level is saying how confident are we that the population parameter will be within the interval that we will be constructing. Our alpha here would be 1 minus the confidence level. So if the confidence level is 90%, 1 minus the confidence level would be 0.10. So we need to take one half of that. We have 0.05. Now, why do we have to take one half of that? We are pertaining to this area on the tails of the normal distribution. So when we say 90% confidence level, we are talking at the 90% of the area under the normal curve. And we expect that the area on the tails would be 0.05 or 5%. So we have two tails. So we have 5% on the left tail, 5% on the right tail, and then we have our 90% where we are trying to estimate our population parameter, or in this example or in this lesson, our population mean. And then our critical value when the confidence level is 90% would be 1.645. We have our confidence level 95%. The critical value is 1.96. Our confidence level 98%. Our critical value is 2.33. And when our confidence level is 99%, our critical value is 2.58.